Hello everyone, and welcome back. Today I'm going to be starting a lecture series on differential equations. Now, a differential equation is a type of equation that relates a function to one or more of its derivatives. So it relates a function to terms that describe how it's changing one way or another, which makes it one of the most applicable areas of mathematics, because things are changing everywhere. Physics describes a lot of things that changes, chemistry, chemical reactions change, and even finance uses a lot of differential equations to describe the flow of economic currencies and such. So the differential equation that we're going to be solving today is one that comes from Newton's second law of motion, so it's from physics. And it's the differential equation that pops out at you if you're trying to find the velocity as a function of time of a falling object. And in this case we're going to ignore air resistance, so our object right here is only being acted on by the force of gravity and it's falling through a vacuum, which will simplify things a great deal. So let's do it. Newton's second law of motion states that the sum of the forces acting on an object is equal to the mass of the object times the acceleration of the object in whatever direction that the forces add up to push it or pull it in. And in this case, the sum of the forces is just going to be our one force that we have acting on the object, which is gravity, which is the mass of the object times acceleration due to gravity. So, writing that in, we have mg is equal to ma. Right away we can simplify it by dividing both sides by m, and so we have just g is equal to a. Now, to make this a differential equation, it's not quite a differential equation yet, we have to add in a differential. So we need to relate one of these terms to how something else changes, hopefully specifically what we're trying to solve for, which is the velocity as a function of time. Now looking at this, you could point out that, acceleration, that's the rate of change or the derivative of velocity. It's how velocity changes over time. So we can write in for acceleration the derivative of velocity, and we'll do that. So we have g on this side is just equal to dv dt. And this is called a separable differential equation. It's one of the more simple kinds to solve, which makes it a good first experience with differential equations. And all you have to do to be able to solve this kind of equation is recognize that dv and dt are not, they don't have to be together. You know, going through Calc 1 and Calc 2, you always see dv dt or, dx dt. They're always stacked on top of one another. But they're actual quantities. They're infinitesimally small, but they do represent a change in some variable. And so they are a quantity, and we can treat them as such, just like other variables, other constants. So we can multiply both sides of this equation by dt to get rid of it on this side, and so we have g times dt on that side is equal to dv. So we have separated our variables. And now we're in a great position to integrate both sides. And this is sometimes one of the harder parts to grasp, because your bounds of integration are going to depend on the initial conditions of your differential equation. So where does the ball start in the air, or how fast do you throw it down initially? But for this example, we're just going to assume that we are dropping the ball. So at a time t equals 0, the ball is going to have a velocity of 0. So we'll start our integration on this side. We'll integrate this side from 0, t equals 0, because we're integrating with respect to time. Our bounds must be in terms of time. We're going to integrate from t equals 0 to some arbitrary t. And that some t is going to relate to some v. After some t amount of time of that ball accelerating downward due to gravity, it has some velocity. So we integrate this side from 0 to whatever the velocity is at that time. And the integral of dt is just t, and the integral of dv is v. So we will have g times t is equal to v. And so our function is v of t, v as a function of time, velocity as a function of time, is equal to acceleration due to gravity times time. And so at any point in time, after you release that ball, you can plug in that value of time right here and find the velocity that much time after you dropped it.